access control as a central element of computer security. The principal objectives of computer security are to prevent unauthorized users from gaining access to resources, to prevent legitimate users from accessing resources in unauthorized manner, and to enable legitimate users to access resources in an authorized manner. So we begin this chapter with an overview of some important context. um, we look at three widely used techniques for implementing access control policies, and we then turn to a broader perspective of the overall management of access control using identity, credentials, and attributes. And finally, we will talk about the concept of a trust framework, um, like just a brief introduction to the trust framework. So we'll begin talking about the two definitions that we have of access control. The first one, um, the first one defined by the NISTIR, defines access control as the process of granting or denying specific requests to obtaining use information and related information processing services, and entering specific physical facilities. So we see that we have one related to services, to digital services, and one related to physical services. The second definitions that we have is the one that by RFC, which define access control as a process by which the use of system resources is regulated accordingly to a security policy, and it's permitted only by authorized identities. This means users, programs, processes, and other systems according to set policy. Now, in this table, we can see a list of security requirements for access control services. Um, Here we can see the basic security requirements and the derived security requirements. In the basic security requirements, we are talking about that basically the information must be limited to the people that are authorized and the people that have been given an authorization by the people from the first group that I just mentioned. The derived security requirements are just some common tasks that people with set access do, like terminating a session, like controlling the flow of CUI, among others. So in theory, all of computer security is concerned with access control. The definition by the RFC says that um, computer security are the measures that implement and assure security services in a computer system, particularly those that assure access control service. So this chapter deals with a narrower, more um, more specific concepts of access control. Access control implements a security policy that specifies who or what, for example, in the case of a process, may have access to each specific system resource and the type of access that is permitted in each instance. Here we can see a broader context of access control. In addition to access control, this context involves some entities and function, like authentication, which is the verification that the credentials of a user or other system entities are valid. We also have authorization, which refers to the granting of a right or permission to system entity to access a system resource. So this function determines who is trusted for a given purpose. We also have an audit, which is an independent review and examination of system reports and activities in order to test the adequacy of system controls to ensure the compliance with established policy and operational procedures, um, to detect breaches in security, like the weak link, and to recommend any indicated changes in control, policy, and procedures to make the whole system safer. An access control mechanism mediates between a user or a process executing on behalf of a user and system resources, such as applications and operating systems, firewalls, routers, files, and databases. The system must first first authenticate an entity seeking access. Typically, the authentication function determines whether the user is permitted to access the system at all. Then the access control function determines if the specific requested access by this user is permitted. And a security administrator, sorry, maintains an authorization database that specifies what type of access to which resources is allowed for this user. So the access control function controls this database to determine whether to grant access or not. And an auditing function monitors and keeps a record of users' accesses to system resources. So in the simple model that we have in this image, the access control function is shown as a single logical module. So in practice, a number of components may cooperatively share the access control function. So all operating systems have at least rudimentary and in many cases a quite robust access control component. So add-on security packages can supplement the native access control capabilities of the operating system, and particular application or utilities such as database management systems also incorporate access control functions. External devices such as firewalls can also provide access control services. Next slide. So an access control policy, which can be embodied in an authorization database, dictates what types of access are permitted, under what circumstances, and by whom. Access control policies are generally grouped into four categories. First, we have DAC, which stands for Discretionary Access Control, RBAC, MAC, and ABAC. In DAC controls access based on the identity of the requesters and access rules, like authorizations, stating what requesters are or are not allowed to do. And this policy is termed discretionary because an entity might have access rights that permit the identity by its own volition to enable another entity to access some resources. Um, so they can enable others to access a specific resource. Then we have the mandatory access control (MAC), in which controls access based on comparing labels with security labels with security clearances. The security labels indicate how sensitive or critical systems resource are, and the clearances indicate systems identity, which system identities are eligible to access certain resources. So this policy is turned mandatory because an entity that has clearance to access a resource may not be its own volition um, enable another entity to access that resource. So we can see like the main difference between DAC and MAC here. Then we have the role-based access control, in which the whole system is based on the roles that users have within the system and on rules stating what accesses are allowed to users in given roles. And last but not least, we have attribute based access control, in which controls access are based on attributes of the user and the resource to be accessed and current environmental conditions. So DAC, the first one that we talked about, is the traditional method of implementing access control, and it's examined further in this presentation. MAC is a concept that evolved out of requirements for military information security and is best covered in the context of trusted systems. Both the FBAC and IBAC have become increasingly popular, and we will further examine those in another video. These four policies are not mutually exclusive. An access control mechanism um, can employ two or even um, three of these policies to cover different classes of system resources. So the basic elements of access control are subject, object, and access right. Subject is an entity capable of accessing objects. Generally, the concept of subject equates with that of process. So any user or application actually gains access to an object by means of a process that represents that user or application. And the process takes on the attributes of the users such as access rights. So a subject is typically held accountable for the actions that they have initiated, and an audit trail may be used to record the association of a subject with security relevant actions performed on an object by the subject. So in this sense, basic access control systems typically define three classes of subjects with different access rights for each class. So first we have the owner, who may be the creator of a resource, such as a file. And for system resources, ownership may belong to a system administrator. For project resources, a project administrator or leader may be assigned ownership, etc., etc. We have a group which, um, like in addition to the privileges assigned to an owner, a named group of users may also be granted access rights, such that membership in the group is sufficient to um, exercise these rights. Um, like yeah exercise the access right. So in most schemes, a user may belong to multiple groups, so may have multiple activities that they can perform. Then we have word. um, for word, the least amount of access is granted to users who are able to access the system but are not included in the categories owner and group for this resource. Um, so an object is a resource to which access is controlled. Um, in general, an object is an entity used to contain and or receive information. So examples include records, books, pages, segments, and files, personal files, directories, directory trees, mailboxes, messages, um, programs. Um, some access control systems also encompass bits, bytes, words, processors, communication ports, network nodes, and the clocks. The number of okay, the number and types of objects to be protected by an access control system depend on the environment in which access control operates and the desired trade-off between security on the one hand and complexity. Processing burden and ease of use, it's on the other hand. So last we have access rights, which I mentioned in the subject part. This describes the way in which a subject may access to an object. Access rights could include read, which allows a user to view information in a resource, like a file, a selected record in a file, a selected field within a record, or some combination of the ones that I just mentioned. Um, and this usually also contains a ability to copy or print said information. We also have the right access, the rights right, in which user may add, modify, or delete data in a system resource. Um, and this obviously includes the read access. We also have the execute right, in which you can execute a specified programs. We have delete, mm, very self-explanatory, create, the same thing. Search, in which user may list the files in a directory or otherwise search directly in the directory. So as we mentioned earlier, the discretionary access control is the scheme in which an entity may be granted access rights that permit that entity to enable another one to access some resource. So a general approach to discretionary access control is an access matrix. One dimension of this matrix would consist of an identified subjects that may attempt data access to the resources. Typically, this list will consist of individual users to user groups, although access could be controlled for terminals, network equipment, host, or applications instead of or in addition to users. Um, the other dimension of the matrix lists the objects that may be accessed, and at the greater level of detail, objects may be individual data files, uh, and more aggregate groupings such as records, files, or even the entire database might also be objects in the matrix. So each entry in the matrix indicates the access of a particular subject for a particular object. So here we have a simple example of an access matrix. Thus, user A over here, user A um, owns file 1 and 3. User B um, has um, a read and write access right, a read and write access right to those files, to the files that user A owns, but they also have um, the read permission for file 4 and own file 2, and so on. This is basically how a simple access matrix looks. In practice, an access matrix actually is actually very sparse. It's implemented by decomposition in one or two ways. So the matrix may be decomposed by columns, yielding access control lists. Um, for example, like we have, okay, so in this part, let's concentrate on this part first. In this part, we have um, an ACL access control list. Every time we say ACL is access control list, we have an access control list, users, and their permitted accesses, right? So the ACL may contain a default or public entry. This allows users that are not explicitly listed as having um, special rights to have a default set of rights. So the default set of rights should always follow the rule of least privilege or read-only access, which whichever is applicable for the case. And elements of the list may include the individual users as well as groups of users. Um, when it's desired to determine which subjects have which access rights to a particular resource, ACLs are pretty convenient because each ACL provides the information, provides the information for a given resource. So, however, this data structure is not convenient for determining the access rights. Um, it's not convenient for determining the access rights available to a specific user. So on the image on the right here, we have a capability list for files of the image that we have on the left. On the left, the composition by row, um, row yield, capability tickets. We have a capability ticket that specifies authorized objects and operations for a particular user. So each user has a number of tickets and may be authorized to loan or give them the others. Um, because tickets may be dispersed around the system, they present a greater security problem um, that than access controls. So the integrity of the ticket must be protected and guaranteed, usually by the operating system. In particular, the tickets must be unforgeable. So one way to accomplish this is to have the operating system hold all tickets on behalf of the users. So these tickets would have to be held in a region of memory inaccessible to users. So another alternative is to include an unforgeable token in the capability. This could be a large random password or a cryptographic message authentication code. Um, so this value is verified by the relevant resource whenever access is required. So this form of capability ticket is appropriate for use in a distributed environment when the security of its context um, content cannot be guaranteed. So the convenient and inconvenient access of aspects of capability tickets are the opposite of those for ACLs. So it's easy to determine the set of access rights that a given user has, but more difficult to determine the list of users with specific access rights for a specific resource. So this is a proposal of a different data structure that is not sparse like this. This is an authorization table that contains one row for one access right in front of one subject to one resource. So sorting or accessing the table by subject is equivalent to a capability list. Sorting or accessing the table by object is equivalent to an ACL. And a relational database can easily implement an authorization table of this type. So in this section, we are presented a general model for DAC. The model assumes a set of subjects, which are over here, and we also have a set of objects, which will be here. So we have a set of rules that govern the access of subjects to objects. So let us define the protection state of a system to be the set of information. At a given point in time that specifies the access rights for each subject with respect to each object, we can identify three requirements: representing the protection state, enforcing access rights, and allowing subject to alter the protection state in such ways. So the model addresses all three requirements, giving a general logic to description of a DAC system. So the represent of to represent the protection state, we can extend the universe of objects in the access control matrix to include like first of all processes in which access rights include the ability to delete a process, stop or block it, and wake up the process. We also have devices. So access rights include the ability to read and write the device, to control its operation, and to block or unblock the device for use. We have the memory locational regions. Um, so in this case, access rights include the ability to read and write certain regions of memory that are protected such that default is to disallow access. We also have subject, which would, like access rights with respect to a subject, have to do with the ability to grant or delete um, access rights of that subject to other objects. So um, in this figure, we have an example of a control matrix. Um, in and for each entry, we have strings called access attributes that specify the rights of subjects to an object. So, for example, in this figure, S sub 1 may read the file F sub 1 because read appears in set position. We have we have here we have subject 1, and here we have file 1, and as you can see, if you read all the way here, you can see that this user can read this file. So that's what we do for each relation between object and subject. Um, from a logical or functional point of view, a separate access control model is associated with each type of object, which we will see in the next slide. We will see how the model evaluates each request by a subject to access an object to determine if the access right exists. So an access attempt um, triggers an algorithm that we will talk about later. So this image suggests that every access by a subject to an object. Um, we have okay, so we have the subjects here all the way on the right, on the left, and we have the objects all the way down here on the right. Um, so this suggests that every access by a subject to an object is mediated by the controller for that object. So that controller's decision is based on the current contents of the matrix. So certain subjects have the authority to make specific changes to the access matrix. So a request to modify the access matrix is treated as an access to a matrix, with the individual entities in the matrix treated as objects. Such accesses are mediated by an access matrix controller, which control the updates to a matrix. So the model also includes a set of rules that govern modifications to the access matrix. Um, so we can see like the first three rules that deal with transferring, granting, and deleting access rights. Um, and we have the authorization of said task. So this means that S sub 0 has access rights A to subject X, and because of the presence of the copy, like the first rule, because of the presence of the copy flag, can transfer with this right with or without copy flag. So we have transferring, we have granting a specific access rights, we have deleting, we have reading, creating, destroying, and creating subjects, destroying subjects, creating objects, and destroying objects. The access control matrix model that we have discussed so far associates a set of capabilities with the user. A more general and flexible approach is to associate capabilities with protection domains. So, um, a protection domain is a set of objects um, together with access rights to those objects. In terms of the access matrix, a row defines a protection domain. So far we have equated each row um, with the specific user. So in this limited model, each user has a protection domain, and any processes spawned by the user have access rights defined by the same protection domain. So a more general concept of protection domains provides more flexibility. For example, a user can spawn processes with a subset of access rights of the user. So define the so if a user can spawn processes with a subset of the access rights of the user is defined as a new protection domain. So this limits the capability of the process, such as scheme could be used by a server process to spawn processes for different types of users. Also, a user could define a protection domain for a program that is not fully trusted, so that so that its access is limited to a safe subset of the user um, access rights. So the association between a process and a domain can be static or dynamic. For example, a process may execute a sequence of procedures and require different access rights for each procedure, such as read file and write file. In general, we could like to minimize access rights that any user or process has at any time. The use of protection, um, the use of protection domains provides a simple means to satisfy this requirement. So one form of protection domain has to do with the distinction made in many operating systems, such as Unix, between user and kernel mode. A user program executes a user mode in which certain areas of memory are protected from the user's use and in which certain instructions may not be executed. So when the user process calls a system, that like a system routine, that routine executes in a system mode, or what has come to be called a kernel mode, in which privileged instructions may be executed and in which protected areas of memory may be accessed. Um, as I was saying, of the Unix file access control, we first introduced like some several concepts concerning Unix files and directories. All types of Unix files are administered by the operating system by means of innodes. And an inode or an index node is a controlled it's a control structure that contains the key information needed by the operating system for a particular file. So several file names may be um, associated with a single node. So and but also an active inode is associated with exactly one file, and each file is controlled by exactly one node. So the attributes of the file, as well as its permission and other control information, are stored in the inode. One on the disk, there is an inode table or an inode list that contains the inodes of all the files in the file system. When a file is opened, its node is brought into main memory and stored in a memory resident inode table. So directories, we have directories. Directories are structured in a hierarchy. So each directory can contain files and or other directories. So a directory that is inside another directory is referred to as subdirectory. A directory is simply a file that contains a list of file names plus pointers associated in nodes. Those associated with each directory is its own node. Um, Most Unix systems depend on, or at least are based on, the file access control scheme, um, which was introduced with the early versions of Unix. Each Unix user is assigned with a unique user identification, like a user ID, um, and initially, a user is also a member of a primary group. Possibly, it can be member of other groups. So each identified group has an ID. So when a file is created, it's designated as owned by a particular user and marked with that user ID. It also belongs to a specific group, which initially is either its creator primary group or the group of its parent directory if that directory has set GID permissions. So associated with each file is a set of 12 protection bits. So the owner, like the owner ID, the group ID, and protection bits are part of the files node, files in node, the index node. So 9 of the protection bits specify read, write, and execute permission for the owner of the file, and the other members of the groups to which this file belongs, and other users. So this form of hierarchy of owner, group, and all other with the highest relevant set of permission is being used. So in the image, we can see an example in which the file owner has read and write access, and all of the other members of the files group have read access. So users outside the group would have no access, like no access rights to a file. So when applied to a directory, the read and write bits grant the right to list and to create, rename, delete files in the directory. So the execute bit grants to the descent into the directory or search to into the directory or search it for a time for a file. So the remaining three bits define uh, special additional behavior for files or directory. Two of these are the set user ID, which is usually referred to set UID, and set group ID, which is set GID. Um, if these are set on an executable file, the operating system functions first when like okay so first when a user with execute privileges for these files executes the file, the system temporarily allocates the rights of the user's ID of the file creator or the files group respectively to those of the user executing the file. These are known as the um, effective user ID and effective group ID, and are used in addition to the real user ID and real group ID of the executing user when making access control decisions for this program. These changes only effective while the program is being executed. So this feature enables the creation and use of privileged programs that may use files normally inaccessible to other users. So it enables users to access certain files in a controlled, a controlled fashion. So alternatively, when applied to a directory, the setDID permission indicates that newly created files will inherit the group of its directory, and the setUID file permission is ignored. The final permission bit is the sticky bit. So when applied to a directory, the sticky bit specifies that only the owner of any file in the directory can rename, move, or delete that file. Um, and lastly, we have a particular user ID, which is designated as super user. And the super user is exempt from the usual file access control constraints and it has system-wide access. Any program that is owned by and set UID to the super user potentially grants unrestricted access to the system to any user executing that program. Hence, great care is needed when writing such programs. Um, this access scheme is adequate when file access requirements align with users and a modest number of group users. So many more Unix and Unix-based operating systems support access control lists, including FreeBSD, OpenBSD, Linux, and Solaris. In this section, we will describe FreeBSD, but in but like other implementations have essentially the same features and interface. The feature referred to as extended access control list, um, while the traditional Unix approach is referred to as minimal access control list. So FreeBSD allows the administrator to assign a list of Unix user IDs and groups to a file by using the set facl command. Um, any number of users and groups can be associated with a file, and uh, each with three protection bits: read, write, and execute, offering a flexible mechanism for assigning access rights. A file need not to have an ACL, but may be protected solely by the traditional Unix file access mechanism. So FreeBSD files include an additional protection bit that includes that indicates whether the file has an extended ACL. FreeBSD and most Unix implementations that support extended ACL use ACLs use the following strategy, in which first the owner class and another class entries in the 9-bit information field have the same meaning as in the minimal ACL case. Second, the group class entry specifies the permissions for the owner group for this file. These permissions represent the maximum permissions that can be assigned to named users or named groups other than the owning user. In this latter role, the group class entry functions as a mask. As a third, we have additional named users and named groups may be associated with the file. So each with a 3-bit permission field um, can or may be associated with the file. So the permission listed for a named user or a named group are compared to a mask field, and any permission for the named user or named group that is not present in the mask field is disallowed. Um, so when a process requests access to a file system object, two steps are performed. So step one selects um, the ACL entry that most closely matches the request process, and the ACL entries are looked at in the following order. Like we have owner, named users, owning or name groups, and the others. So only a single entry determines access. And on step 2, we check if the matching entry contains sufficient permissions. So a process can be a member in more than one group. So more than one group entry can match. So if any of these matching group entries contain the requested permission, one that contains the requested permissions is picked, the result is the same no matter which entry is picked. If none of the matching groups entries contains the requested permissions, access will be denied no matter which entry is picked. Um, So constraints provide a means of adapting RBAC to the specific of administrative and security policies of an organization. So we have first the mutually exclusive roles, such are roles such that a user can be assigned to only one role instead. We have um, we have cardinality the cardinality constraint in which um, we set a maximum number of with respect to roles, and a system might be able to specify a prerequisite role which dictates that a user can only be assigned to a particular role if it's already assigned to some other specified role. So a prerequisite can be used to structure the implementation of the least privilege concept. A relatively recent development in access control technology is the attribute-based access control model, um, also like sometimes referred to as ABAC. ABAC model can define authorizations that express conditions on properties of both the resource and the subject. For example, consider configuration in which each resource has an attribute that identifies the subject that created the resource. So then a single access rule can specify the ownership privilege for all the creators of every resource. Um, the strength of the ABAC is that the flexibility and the expressive power. So the main obstacle to its adoption in real system has been concern about the performance impact of evaluating predicates on both resource and user properties for each access. So mm, however, for applications such as cooperating web services and cloud computing, this increased performance cost is less noticeable because there is already a relatively high performance cost for each access. Thus, web services have been pioneering technologies for implementing ABAP models, especially through the introduction of the extensible access control markup language. And there is considerable interest in applying the um, ABAC of applying the, the ABAC model to cloud services. Um, there are three key elements to an ABAC model. Attributes, which are defined for entities and configuration, a policy model, which defines the ABAC policy, and an architecture model, which applies to policies that enforce the control. We examine these elements. Um, So we have the subject attributes, the object attributes, and the environmental attributes. The attributes are characteristics that define specific aspects of the subject. Object, environment, environmental conditions, requested operations that are predefined and pre-assigned by an authority, etc., etc. So attributes contain information that indicates the class of information given by an attribute, like name, value, whatever, like according to each case. Um, Subject attributes, like it's like a user, like an application, a process or a device that causes information to flow among objects or changes the system state. So each subject has associated the attributes that define the identity and characteristic of the subject. And the such like these attributes may contain an identifier, name, organization, job title, so on. So a subject role can be also viewed as an attribute. So then we have object attributes, or resources attributes. Um, it's more like devices, files, records, tables, processes, programs, um, domains, or networks that contain or receive information. So they have attributes, of course. These attributes, um, for example, a Microsoft document, it may have attributes such as a title, a subject, date, an author, among others. Um, and in particular, a variety of web service metadata attributes may be relevant for access control purposes, such as ownership, service taxonomy, even quality of service attributes. And last, we would have the environmental attributes, which have been, like before, this model had been ignored in other access control policies, and these describe the operational, technical, and even situational environment or context in which the information access occurs. Um, for example, attributes such as current date and time, current virus or hacker activities, the network security level, internet or intranet, Like these kind of things are not associated with a specific subject nor a resource. It's but it's relevant enough um, to not be ignored. It's irrelevant in applying an access control policy. Um, so for this access control model, um, this is kind of distinguishable because it controls access to objects by evaluating rules against the attributes of entities. So we have subjects and objects. So operations and the environment, like in general, the environment is relevant to our request. So ABAC relies upon the evaluation of attributes of the subject. So attributes of the subject, attributes of the object, and a formal relationship or access control rule defining the allowable operations for subject-object attribute combinations in a given environment. All ABAC solutions contain this basic core capability to evaluate attributes and enforce rules for relationships between those attributes. In this image, we have a logical architecture, um, like the essential components of an ABAC system. So an access by a subject to an object can like proceeds according to the steps that we're seeing here. Like first, we have a subject who requests access to an object. So the request is routed to an access control mechanism. So the second step would be the like what has to do with the access control mechanism, which is governed by a set of rules. The rules would be to like um, the ones that are defined by a pre-configured access control policy. Based on these rules, the access control mechanism assesses the attributes of the subject. The subject that would be to be, the attributes of the object that would be to be, and the current environmental conditions that would be to be. The access control mechanism grants the subject uh, access to the object if access is authorized and denies access if it's not authorized. So it's clear from the logical architecture that there are four independent sources of information used for the access control decision. Um, so the system designer can decide which attributes are important for access control with respect to subjects, objects, and environmental conditions. And the system designer um, or other authority can then define access control policies in the formal rules for any desired combination of attributes of subjects, objects, and environmental conditions. This approach is kind of very powerful and flexible, but the cost in both terms of the complexity of the design and the implementation and in terms of the performance impact is likely to exceed that of other access control approaches. It is a trade-off that the system authority must make. Um, this image provides a useful way of grasping the scope of an ABAC model compared to a DAC model using access control list, the the ACLs. This figure not only illustrates the relative complexity of the two models, but also clarifies the trust requirements of the two models. So a comparison of representative trust relationships for ACL and for ACL use and ABAC use shows that there are many more complex trust relationships required for ABAC to work properly. Um, we now examine some concepts that are relevant to an access control approach centered on attributes. This section provides an overview of the concepts of identity, credential, and access management. So ICAM, Identity, Credential, and Access Management, is a comprehensive approach to managing and implementing digital identities, credentials, and access control. Um, it's okay. Even though it was developed by the U.S. government, it's applicable not only to government agencies but also may be maybe developed deployed by enterprises looking for a unified approach to access control. It's designed to mainly create trusted digital identity representations of individuals and non-personal identities. Um, the latter include processes, applications, and automated uh, devices seeking access to a resource. Um, being those identities to credentials that may serve as a proxy for the individual or NP in access transactions. A credential is an object or data structure that authoritatively binds an identity and optionally additional attributes to a token possessed and controlled by the subscriber. Um, this method, this approach, use the credential. It's designed to use the credential to provide authorized access to an agency resources. Um, This, here we can see an overview of the logical components of an ACAM architecture. Um, these are, we'll examine these components in the following subsections. First, we have then identity management, which is concerned with assigning attributes to a digital identity and connecting that digital identity to an individual or an NPE. The goal here is to establish um, a trustworthy digital identity that is independent of a specific application of or context. The traditional and still most common approach to access control for application um, is to create a digital representation of an identity for a specific use of the application program. And as a result, the maintenance and protection of the identity itself is treated as secondary to the mission associated with the application. Further, there's considerably overlapping effort in establishing these application-specific attributes. So as we mentioned before, a credential is an object or data structure that authoritatively binds an identity and optionally additional attributes to a token possessed and controlled by subscriber. So as an example of this, we can mention smart cards, private and public cryptographic keys, digital certificates, among others. Credential management is the management of the life cycle of a credential. It follows like five components. Like first is when you establish the need for the credential, like for example, a department supervisor sponsors a department employee. Second, we have the like the enrollment, and the sponsored individual enrolls for the credential, a process which typically consists of identity proofing and the capture of biographic and biometric data. Um, then we have the producing of said credential, like depending on the credential type, production may involve encryption, the use of a digital signature, the production of a smart card or other functions. Then we have the credential being issued to the individual or the entity, and finally the credential must be maintained over its life cycle, which might include revocation, reassurance, replacement, enrollment, re-enrollment, expiration, personal identification number being reset, suspension, or reinstate, instatement. The access management component deals with the management and control of the ways entities are granted access to resources. So it covers both logical and physical access and might be internal to a system or an external element. Um, the purpose of access management is to ensure that the proper identity verification is made when an individual attempts to access security sensitive buildings, computer system, or data. The access control functions makes use of credentials presented by those requesting access and the digital identity of the requester. Three support elements are needed for a enterprise-wide access control facility. First, we have the resource management, privilege management, and policy management. Um, so first, to speak about resource management, this element is concerned with defining rules for a resource that requires access control. The privilege management refers to the establishing and maintaining the entitlement or privilege attributes that comprise an individual access process, like an individual access profile. These privileges are considered attributes that can be linked to digital identity. And last, we have the policy management, um, which governs what is allowable and unallowable in an access transaction that is given the identity and attributes of the requester, the attributes of the resource or object, and environmental condition. A policy specifies what actions this user can perform on this specific object. Then we have the identity federation. This is described to like this term is used to describe the technology, the standards, the policies and processes that allow an organization to trust digital identity. So we have two main questions. Like the first one would be how do you trust identities of individuals from external organizations who need access to your system? And the second one would be how do you vouch for identities of individuals in your organizations when they need to collaborate with external organizations? So we will have a brief discussion about this. Um, Online or network transactions involving parties from different organizations or between organizations and individual users, such as an online customer, generally require the sharing of identity information. This information may include a host of associated attributes in addition to simple name or numerical identifier. Both the party disclosing the information and the party receiving the information need to have a level of, of, trust about security and privacy issues related to that information. So in this image, we have the traditional technique for the exchange of identity information. This involves users developing arrange developing arrangements with an identity service provider to procure digital identity and credentials, and arrangements with parties that provide end user services and applications and that are willing to rely on the identity and like the credential the the credential information generated by the identity service provider. Um, Without some universal standard and framework, the arrangement of the figure that we saw on the previous slide um, must be replicated in multiple contexts. So a more preferable approach is to develop an open, standardized approach to trustworthy identity and attribute exchange. In the um, in what's left of this section, we examine such an approach that is gaining increasing acceptance. Um, we have OpenID, which is an open standard that allows users to be authenticated by certain cooperating sites known as relying parties, like using a third-party service, eliminating the need for webmasters to provide their own ad hoc systems, and allowing users to consolidate their digital identities. Users may create accounts with the preferred OpenID identity providers and then use those accounts as the basis for signing on to any website which accepts OpenID authentication. Then we have the um, OIDF, the OpenID Foundation, which is an international not-profit organization that that is committed to enabling, promoting, and protecting OpenID technologies. Then we have the ICF, which is the Information Card Foundation, which uses information cards that are personal digital identities that people can use online and the key components of identity meta system. Visually, each information card has like a card shaped picture and a card name associated with with that enable people to organize to organize their digital identities and to easily select one they want to use for any given interaction. Then we have the OITF, which is the Open Identity Trust Framework, which is standardized. It's open specification of trust framework for the identity and attribute exchange developed by OIDF and ICF. Then we have OIX, which is the Open Identity Exchange Corporation, which provides certification of trust frameworks conforming to the Open Identity Trust Framework model. Then we have the Attribute Exchange Network, um, which is an online internet scale gateway for identity service providers and relying parties to efficiently access user-asserted permissioned and um, verified online identity attributes in high volumes at affordable cost. Um, so these are the main elements involved in OITF within any given organization or agency. One of the main um, roles is the relying parties. These are the service providers um, which are delivering a specific to users. These must have confidence in the identities and or attributes in their intended users and must rely upon the various credentials presented to evince those attributes and identities. We have the users for the subjects that are the users of an RP service, including customers, employees, trading partners, subscribers, etc., etc. We have the attribute providers, which are the entities acknowledged by the community of interest as being able to verify given attributes as presented by subjects, and which are equipped through the AXN to create conformant attribute credentials according to rules and agreements of the AXN. We also have identity providers, the IDPs, which are able to authenticate user credentials and to vouch for the names of subjects and are equipped through um, the AXN or some other compatible identity and access management system to create digital identities that may be used to index user attributes. We have some support elements like the assessors, who are the ones that evaluate the identity service providers and RP and certify that they are capable of following the OTF provided blueprint. We have the auditors, which may be called on to check that parties' practices have been in line with what was agreed on the OITF. We also have the dispute resolvers, which are the ones that provide arbitration and dispute resolution. We have the trust framework providers. Um, that is basically like an organization that translates the requirements of policymakers into an own blueprint for a trust framework that it then proceeds to build, doing so in a way that is consistent with the minimal requirements set out in the OITF specification. Um, So, in summary, we saw some access control principles. We talked about the access control context, the access control policies, the subjects, and access rights, the discretionary access control, the access control model, protection domains, um, and the different types of access control that we have, the airbag, the ABAC, the MNC, among others. We have the identity, credential and access management, and the trust frameworks.